chat about this common error I saw on your pretest. Obviously on the pretest there was a trig function involved too, but it was the algebra that really, killed my soul a little bit. So what was wrong here? Fifth block had no idea. They thought it was right.
A lot of people did this on the pretest.
Raise of hands, who thinks this is right?
I don't think you're allowed to. That's wrong.
They're like, nah.
Square it.
Square it.
Isn't that how you get rid of the radical?
If you wanted to get rid of the radical, I'm going to tell you you're not getting rid of the radical in this.
So, okay, is subtracting the root 3 right? Is that what we're supposed to do? No?
They messed up in this step right here. Thank you. Thank you. You're the first person to have said that. So remember, the square root's kind of like it gets to stay there, but there's this imaginary 1 right here. So you actually end up with 4x equals 2 root 3. Oh. And then when you divide the 4, you end up with 2 root 3 over 4. And then what do? You simplify. We end up with root 3 over 2. Oh my gosh, and that's like something we see all the time.
Yeah.
I mean, yeah, because you all did it so wrong that you wouldn't have seen it.
I didn't even process that it was algebra that we're supposed to be doing that. I just like literally.
We're going to get a lot more into that, is that like all of the things that we're doing, there's like this little trig function to send you into a panic, but it's literally all just algebra. Like we're going to do quadratic formula with trig, right? Like it's going to be so much fun. Disgusting. Okay. So, looking at this, I crossed the 1 out because it was the exact same as the other one. So that's just big fat bummer. But the ones that are currently starred in red, I believe that you should be able to complete.
This is our bell work?
Yes, this is your bell work. And we'll chat about how to do the other ones. Yes, the red starred ones. You can just write it. Anybody have homework for me?
We haven't even a new homework, or just the one from yesterday?
The new homework isn't due until
No.
Wednesday, Thursday.
next
Oh.
next Tuesday. Although, if we're counting the 2 Canvas assignments that exist.
The two? Right.
Yeah, we have the SAT prep.
Yeah.
Guys, I know I briefed you on this. Yeah, on Canvas, not decided by me, not decided by Miss Bryant. We were instructed to give you SAT prep, even if
Is that our assignment for tomorrow?
That's me. That's my fault. I forgot that it was over there. Sorry.
Do you want me to bring you the little mousy thing?
Yes, please. Sorry.
How much time?
I'm not even done with the first one.
It would be awfully hard to write stuff down in notebooks anyway all the time. Yeah. It's like.
No, the video was supposed to be like no, I think I took after 6 years there.
Oh, yesterday?
Yeah.
Yeah, I accidentally posted to private, but since this morning it is now available. I'm gonna get it completely right tomorrow, I promise you that. We can move on. 1 minute, 2 minutes, 7 minutes, 25. Okay, I can't do that.
How about 10?
Nice try, bro. It's either 1 or 2.
Wait, you said 7 minutes at first?
7 was a joke. You just have to do the red starred ones. It's 4 problems.
I'm confused. Give me a second, please.
Hey, before you. I'm still working on that.
Did it make sense to you? Did it make sense to you? The red star one?
Yeah, no, I feel like giving up right now because you don't get it.
Yeah. So if the inverse is on the inside, that 1 is telling you that it's a coordinate. So you're looking for a coordinate that is equal to 1. And then you replace that entire middle chunk with the radius.
Okay, then I got it.
Wait. Aha.
Haha.
I think.
We can move on.
Wait, I think I lied. Never mind.
All these will still be rankings, correct? Every answer will still be rankings.
No, I don't know. I really don't know. I'm really struggling.
Okay, is everyone ready? Or as ready as you're gonna be. So I'm gonna start with the ones that are the same. What's our rule for when the composition functions are the same?
Wait, which one was
Oh, it's the same
star?
rankings.
I thought
It'd be
we
the
were
same,
doing
the exact same thing.
We're not doing the secant with the cosine?
We are. I'm skipping that one because it's the only one that we have to do actual work on, which we'll see in a second. But what's our rule when the trig functions are back to back and they're the same? It's the same answer as long as the radians in the center are within the range of our inverse function. Sine exists in what 2 quadrants?
1 and 2. Oh, 1 and 4.
1 and 4. Is pi ace in either 1 or 4?
No.
Oh, it's 2 and 1.
I is not.
Yes.
Pi ace is the same thing as 1/8.
And 1 and 4, we got that?
1/8. Is 1/8 in between negative 1/2
I didn't look at the right.
and 1/2?
Sorry, I'm just really confused.
It is. Okay, so our little things just cancel right out. Bow. And we end up with the same answer that we had in the middle. Moving over here, is 4 pi fifths, first of all, is cosine, or what 2 quadrants is cosine in? 1 and 2, is 4 pi fifths in either 1 or 2? Yes, it sure is. Bounce.
So is it 1 or 2 basically just?
As long as your back-to-back trig functions are in, as long as your back-to-back trig functions and this radian value is within their range, you just cancel them. So secant,
Where did you get the 4 pi x from?
it doesn't always have to be on the unit circle. It so
Oh, okay, well, we didn't go over that. We didn't. I didn't know that it could be in the range.
we've talked about it though.
I thought it was only the.
Yeah,
You will almost always find it on the unit circle, but 4 pi fifths exists on the unit circle. We just don't put a value there.
Okay, well, I thought we were just using.
I mean, we are, but again, we've talked about that. So, secant, what 2 quadrants did we decide that they were in yesterday?
You said secant, we talked about.
Secant is in, is it?
Two and
It's 1 and 2, because it's just like its sister. Is 7 pi tenths in quadrant 1 or 2? Natalie says 2, so we just literally write. Moving back up here.
And over here, it's 6 over 6 because it's pi. I just want to get the other numbers. So since it's 10, this is 0 over 10. This will be 10 over 10. And if it falls in between those numbers, then
So this 1 is representing a coordinate value since we have the inverse right next to it. So where on our unit circle is the coordinate value of cosine? So the x value, where is that equal to 1? 0. So this entire middle thing goes to 0. So now we have the secant of 0. Secant is what in terms of x and y? So at the radian value 0, what is secant?
Is it not 1 over 0?
The x value at 0, though, is what? 1. So 1 over 1 gives you 1. The next couple problems are going to be some more that are not necessarily on our unit circle. However, they are solvable because of the fact that they have a square root on top and a whole number on the bottom. So you see how all the ones that I don't have starred all follow the same kind of pattern? Their numbers are all different, but they all have a square root and a number on the bottom. So, because of that, we will actually solve it much like we solved our problems where we were given x, y, or coordinates on our test. So, this is y, this is r. In order to find the tangent, you're going to need an x. So you have an x squared plus root 5 equals 4 squared. X squared plus 5 equals 16. X squared equals 11. X equals root 11. So, my tangent is y over x, so that will be a root 5, root 11. That's just the Pythagorean theorem. Because we knew that we would need it for the tangent. So on this one, what is cosecant in terms of x, y, and r? It's r over y. So we have some of the same players, but we're looking for an x over r over here. X squared plus 5 squared equals root 2 squared. X squared plus 25 equals 2. X squared equals negative 23. Does anyone have like major alarm bells going off right now? You should. X squared equals negative 23. Because I subtracted my... Oh, that's a square root of 2.
That's 2.
It's a 5. If we were to square this number, we would be squaring a negative number. Can you do that? Because you would end up with a complex number, and I'm mean, but I'm not that mean. So this is where we would get to put no solution.
So you can't list it. Why is it too small?
Because you'd be squaring a negative number, and you would end up with a complex number, and we don't need to. So I'm going to get you started here. Tangent is y over x. Sine is y over r. You do the Pythagorean theorem and find me my tangent. Osmo, where's your friend?
I think he's sick.
He's turning it into a 6-day weekend.
What?
6-day weekend.
Oh, it's 6 days, we got it. It's 6 days.
We don't have room Friday?
You do, but a bunch of people have indicated that they aren't coming. So. You guys don't want to spend Valentine's Day with us?
I mean, is there gonna be candy?
We're playing a
So
game.
at my little sister's school, they
Can't bring in candy.
at all.
Wait, why?
And if they do bring candy or anything, they take it, they confiscate it, and they say they'll give it away to their family.
Like children.
Why are they?
Because,
Kind of evil.
yeah, well, times are changing. So. I don't know if it's for the better or for the worse.
I think it's for the worst, like, they're gonna do it either way, so why not just do it in a, professional way? Like, how come the high schoolers get to have more fun?
Is that it? No. You still have 10 more minutes. Did everyone get what I got?
I also got no solution.
Okay.
I'm not quite a fan of this.
Well, I didn't make it up.
Alright.
Okay. So,
Should I make a new page for this?
yes, you're actually going to like these much better. I think that was out of order.
Are you the problem?
What should I title?
You what?
Are you the problem with just doing a homework setting?
Yes. Or no. Yeah. So it says find all of the solutions to the following problems on the interval 0 to 2 pi. Oh my God. I'm not teaching this because I want to know it. I'm teaching it because you guys need to know it. That's what I thought. So on the interval 0 to 2 pi, so now instead of just having a restricted domain, you're going to look at this value and you're going to find every place where this cosine equals that. So you should have,
If it's negative or positive, just.
Do we have a second to write it down?
you should have 2 answers for all of these type of problems.
This is gonna be hard to do out of unit circle, right?
It would be very hard without a unit circle.
So, I haven't had a unit circle. Are there any
Yeah, in the extra copies, there's the orange unit circle right there. So if you're looking at your unit circle, where is the cosine equal to 1/2? I heard what? Pi over. I'm going to be picky. Your answers should be in unit circle order. So it should be from the biggest to the smallest. So you should start in quadrant 1 and work your way to quadrant 4.
Wait, why is there 2 radians?
Because there's 2 times where the cosine value is equal to 1/2.
Oh, so you write both.
You write both of them. That's what it means by find all solutions. And that's why I said each of these are going to have 2 answers.
So you go in order.
Yeah. You write them in interval notation and in the order that they appear on the unit circle. So, David, tell me, where can you find negative 1/2? The sign equal to negative 1/2.
No.
You what?
For sine?
Sign.
Yeah.
We're looking for all of the places that it equals negative 1/2. Okay, that's one of them. The denominators should match. Yeah. And that's a solid check for yourself too. If your denominators don't match, you probably have done something wrong. Mm-mm. No, so because there's no inverse, we don't have any arctan here. We just have the cosine equal to, the tangent equal to, the sine equal to. So that's why we just are looking for values. Now, did anyone, when I recommended you do it the other day, write down the tangent values at the locations? Hurrah. So in the first quadrant, what value was root 3 over 3?
What radians?
Mm-hmm.
Pi over 6.
Okay. So if we were looking for a negative version of that, what 2 points look very similar to those coordinates, but they have negative values now?
What's your 2 points?
Is this making sense to everyone?
Wait.
So on your unit circle,
Yes. It does make sense.
tangent is y over x. So we did the work the other day to find our possible tangent values. We found them to be 0, 1, root 3, root 3 over 3, and undefined. Those are your possible values. You will find them all throughout the unit circle. Yeah.
Where is it, 0, 1 and undefined again? Wait, I have
1 is at root 2 over 2. 0 is when the y is on top. So that would be 0 and pi. But if the y was on, or if the bottom value is a 0, so like for example at 0, 1, that would be undefined since it's over a 0.
Okay.
So you will find these 5 values over and over and over again throughout the circle, but just in different negative and positive variations. So now, fly free birdie, I'm making you do these by yourself. And then I'm going to call on people to tell me their answers. So you better do it. Okay. Ariel, have you found your cosine values for 0? You did? What'd you get? Period. Go to my go. Either Jaden. Yeah.
And then 7 pi. Oh, no.
If it's a positive y value, it should be in the first top 2 quadrants. Natalie, have you done? Oh no. Have you done tangent of -1?
3 pi over 4. And 7 pi over 4.
Yay! So,
Wait, what was it?
oh, sorry. The next thing that we're going to do is we're going to find general rules for it. So we'll talk about that on Friday. So you should be here so we can all chat about it.